Welcome dear audience, student and scholars. Here I'm Dr. Amjad Ali. In this video we are going to discuss about measures of dispersion for ungrouped data. Dear scholars, the measures of center tendency which we have discussed in our separate videos such as mean, median and mode do not explain the whole picture of the distribution of a data set. Two datasets with the same mean may have completely different spreads. The variation among the values of the observation for one dataset may be much larger or smaller than for the other dataset. So here we use the word dispersion, a spread and variation as a synonym. So consider, for example, we have the data of two companies workers ages, like company 1 workers age starting from 47, 38, 35, 40, 36, 45, 39, and the second company workers ages 70, 33, 18, 52 and 27. Here one thing to notice that the mean age of the workers in both these companies is the same, that is around 40. If we do not know the age of individual workers at these two companies and are told only that the mean age of the workers in both companies is the same, we may deduce that the workers at these two companies have a similar age distribution as we can observe. However, the variation in the workers' age for each of these two companies is very different. Like if we see the age distribution for the company A like that, and the company second or 2, that is the age distribution like that. So we can see the ages of the workers at the second company have much larger variation as compared to the ages of the workers of the first or one company. Thus the mean, median or mode by itself is usually not a sufficient measure to reveal the shape of the distribution of a dataset. The measures that helps us learn about the spread a dataset are called the measure of dispersion. The measure of center tendency and the dispersion taken together give a better picture of a data than the measure of center tendency alone. There are some famous types of measures of dispersion. First one is range, variance and standard deviation. There are some others, but following some particular course outline, we are only explaining these three: range, variance and standard deviation. So let's explain the term range. The range is the simplest measure of dispersion to calculate. It is obtained by taking the difference between the largest and the smallest value in the data set. So for this purpose we can use the formula for the range: the largest value minus smallest value. Let's see an empirical example for this purpose. We have the total areas in the square miles of 4 United States states. Let's say we have first state, second, third and fourth, and we have to find the range of this data set. The maximum value for a state is 2 lakh 67,277 square miles, and the smallest value is 49,651. So we have the range formula, that is the largest value minus smallest value, and we have the range answer, that is 2,17,626 square miles. Thus the total area of these four states are spread over a range of 2,17,626 square miles. The range, like the mean, has the disadvantage of being influenced by the outliers. If the state of the fourth number can be viewed that its area is 2,67,277 square miles, it dropped. The range from three states will be very small. So consequently, the range is not a good measure of dispersion to use for a data set that contains outlier. Another disadvantage of using the range as a measure of dispersion is that its calculation is based on only two values, the largest and the smallest. Here we have the largest and smallest. All other values in a data set are ignored when calculating the range. Thus, range is not a very satisfactory measure of dispersion. So for further explanation of the dispersion, we can use the variance and standard deviation. Dear scholar, the standard deviation is the most used measure of dispersion. The value of standard deviation tells how closely the value of a data set are clustered around the mean. In general, a lower value of the standard deviation for a data set indicates that the values of that data set are spread over a relatively smaller range around the mean. In contrast, a larger value of standard deviation for a data set indicates that the values of data set are spread over a relatively larger range around the mean. So the standard deviation is obtained by taking the positive square root of the variance. The variance calculated for population is denoted by sigma square. We can write it sigma square, or we can read it as a sigma square. And the variance calculated for the sample data is denoted by small letter s square. Okay, consequently, the standard deviation calculated for the population data is denoted by sigma, and the standard deviation calculated for the sample data is denoted by S. Following are what we will call the basic formulas are used to calculate the variance. Like we have sigma square is equal to summation x minus mu whole square divided by n. This is for the population variance, and this is for the sample variance. S square is equal to summation x minus x bar whole square divided by n minus 1. So sigma x square is population variance and S square is for sample variance. Dear scholars, here quantities like x minus mu and x minus x bar are called the deviation of the x value from the mean. The sum of deviations of the x value from mean is always 0. So that's why if we cannot take the square of this formula, we have summation x minus mu is equal to 0. So let's see a numerical example for the further understanding about the variance and standard deviation. Here we have the midterm score of a sample of 4 students, that is 82, 95, 67 and 92. Okay, we have to calculate the variance of this data. So first we have to calculate the mean value, that is x bar is equal to 82, 95 plus 67 plus 4, and by adding these values and then dividing by 4 we get the 84, and we know that this is for the sample case. So deviation for the 4 score from the mean can be calculated as we have x values and x minus 1, we can get the deviation like that, minus 2 plus 11 minus 17 plus 8, and we have the sum is equal to 0. Okay, from the calculation point of view, it is easier to be more efficient to use the shortcut formulas to calculate the variance and standard deviation. By using the shortcut formulas, we reduce the calculation time and a round of error as well. So for this purpose we can use the shortcut or alternative method, that is sigma square is equal to summation x square is equal to summation x whole square divided by n divided by n. So this is our population variance, and for the sample we have s square is equal to summation x square minus summation x whole square divided by n minus 1. So we know that this is for the population and this is for the sample variance. The standard deviation can be obtained by taking the square root of these two, which we will explain in our coming slides as well. So let's see another example for the further understanding about the standard deviation and variance. Here we have the data related to the market values of 5 international companies during 2008, and we have to calculate the variance and standard deviation for these data, and we have the formula for the standard deviation, sample standard deviation, that is s square is equal to summation x square minus summation x whole square divided by n over n minus 1. So first we have to calculate summation x. Actually this is our first part. We have to calculate summation x, and then we have to calculate summation x square, and then put the values of these terms into the formula, and then we can divide it n minus 1, and we get the variance of this sample data. So for this purpose we first sum of the summation x is equal to 662 and summation x square, and take the square of these values, and we get the summation x square is equal to 1,14,600. Okay, by putting these values into this sample formula, we get the variance for these 5 companies is 6,737.80. So for getting the standard deviation of these 5 companies, we take the square root of variance. So we get the standard deviation for these five companies, and the standard deviation of the market values of these five companies is $82.08 billion. That the standard deviation give us the level of dispersion among the selected firms. Okay, here we have the two observations keep in mind while finding the variance and standard deviation. First, the values of variance and standard deviation are never negative. Dear scholars, that is, the denominator in the formula for the variance should never produce a negative value. Usually the values of the variance and standard deviations are positive, but if a data set has no variation, then the variance and standard deviation are both zero. For example, if we have a data of a 4-person age, like the 4-person age is 35, 35, 35. If we calculate the variance and standard deviation for this data set, their values or variance and standard deviation values is equal to 0. This is because there is no variation in the values of this data set. The second observation is that the measurement units of variance are always the square of the measurement units of the original data. This is so because the original values are squared to calculate the variance. The measurement unit of the original data are billions of dollars, which of course does not make any sense. But the measurement unit of the standard deviation are the same as the measurement unit of the original data, because the standard deviation is obtained by taking the square root of the variance. So let's see another example for the further understanding about the variance and standard deviation. Here we have the earning data of 6 employees of a small company, or all 6 employees of a small companies during 2008. That is 88.5, 108.4, 5.50, like that. So we have to calculate the variance and standard deviation of this data. So first we have to provide which formula we are going to use for measuring the variance. So we are going to use the formula for the variance, that is sigma square is equal to summation x square minus summation x whole square divided by n, because we are using the all implies information. So that's why we have a population formula for this purpose. So first we have to calculate the summation x, that is 449.30, and then we have to take the square of this series, and we get summation x square is equal to 35 or 35,979.5. Okay, then we put these values into the variance formula, and we get 388.9. So this is the variance of our 5 implies, all 6 implies earning from a small company. Okay, then the standard deviation can be obtained by taking the square root of variance, and we get this. We are taking the square root of this, we get the standard deviation answer is 19.721. So that is equal to 19,721. Thus the standard deviation of the earnings of 6 employees of a small company during 2009 is 19,721. Okay, let me give you some other notations about population parameters. But while further going to the other slide, let me highlight that summation x square is not the same as summation x whole square, because the value of summation x square is obtained by squaring the value of this part. So that's why these two terms are not same or not alike to each other. Okay, let's discuss about the population parameter and sample statistic, which we have gone through our previous sessions, but here we are only giving the interpretation as I have highlighted a few seconds ago. Okay, numerical measures such as the mean, median, mode, range, variance or standard deviation calculated for a population dataset is called a population parameter or simply a parameter, whereas a summary measure calculated for a sample dataset is called a sample statistic or simply a statistic. And we can use mu and sigma for the population parameters, and x bar and s small letter for use as a sample statistic. Okay, dear scholars, let's discuss about the coefficient of variation. Dear scholars, one disadvantage of standard deviation as a measure of dispersion is that it is a measure of absolute variability and not of relative variability. Sometimes we may need to compare the variability of two different data sets that have different units of measurement. The coefficient of determination the coefficient of variation is one such measure. The coefficient of variation denoted by CV expresses standard deviation as a percentage of the mean and is computed as follows. So for population, we have coefficient of variation S divided by x prime or x bar multiplied by 100 for sample data, and coefficient of variation is equal to sigma divided by mu multiplied by 100 is for population data. Dear scholars, when we actually making the comparison of two data series, we can use the coefficient of variation. Let's see, here we have coefficient of variation of any data is equal to 41.63%, and the other data set coefficient of variation is 37.15%. The coefficient of variation for one sector, for first sector, is larger than other sector. So standard deviation and variance give us the variation of the data around the mean, but the coefficient of variation give us the information of relative change or relative value of one data series to another data series. So this is all about measures of dispersion for ungrouped data set. So see you with another video. Ciao.